Hello. Remember when we started learning C? Usually, in the first few weeks, we encounter functions, and then soon after, life becomes hard and we encounter pointers. One of the classic examples in which both these things come together is the swap function, in which we understand for the first time pass by value and pass by pointer. But then something interesting happens in the subsequent weeks when we first use the sort function. This is the first time, if you notice carefully, that we pass a pointer to a function into the function itself. Usually, we just gloss over it. Hi, I am Dushyant, and today I want to fill that knowledge gap. As I was digging deeper into how classes operate, I realized that I just couldn't memorize syntax rules and believe that they'll stay in my head. That just doesn't sit with me. I am a first principles thinker, and the only way that I was going to do it was if I could understand the mechanisms that classes operate on under the hood. That is indirection, virtual, and thunk functions. So, are you ready to go down the rabbit hole with me? Welcome to another vlog in my journey to master C++. Today, I continue my journey by exploring function pointers and slowly taking a practical example, building upon them to pointers to member function and then to virtual functions and get a flavor of how C++ classes actually work under the hood. So let's dive in. Let's start with the quicksort function over here. So I'll just compile this and run it. And as you can see, this is just a regular quicksort function. So I will not go into the algorithm detail over here, but the outline is like this, that first we partition the array around the pivot and then recursively sort the left and the right side of this partitioned array till we get to a single element, that is the sorted base case. Now the most important line in this function is this one, where we compare every element in the array with the pivot and to ensure that we get the correct partition. Now this is where we want to make the change. Now what if we want to reuse the same sorting code but customize how items are compared? For example, what if we want to sort the integers in ascending or descending order without rewriting the whole function? That is where function pointers come in. So, what are the changes that we need to make? What should our compare functions look like? One of the simple functions that we can make to replace that comparison is this one. So as you can see, it's exactly the same as this comparison, but just extracted out in a function. Similarly, we can write something similar if we want our sort to be in a descending order. Okay. Now that we have written this function, we'd like to pass this into our quicksort function and use it. As you remember, when we put an and before something, that just means the reference to it. So we want to send a pointer to this function by using this and keyword. Actually, we can send it without and as well. In C++11, it just automatically decays to a pointer, but for the sake of understanding, we will keep this and. But how do we accept a function pointer in a function? So the syntax for a function pointer is simply this, and it is pre with the return type in front and the parameter list inside the bracket. So if we do this, we are passing a function with this signature into the quick sort. If we have to give this function a name, suppose for example we want to send it in the other calls to quicksort as well, we can name it after the inside the first bracket over here. So we are calling it CMP. So far so good, no errors there. We also need to send it into the partition function. Great. So what have we done here? Our compare functions take two pointers, two integers, and returns a boolean. Once we've defined the signature and the functions, we add it as a parameter to quicksort and then pass it in the logic we want, ascending or descending. Great. Now we have defined the signature and we have added as a parameter to quicksort. Now let's make the change at the point of comparison. Right? Why is this? Oh, not the reference. It's taking a. Yeah. So this should. Let's compile the program and see what we've got. Yeah. And congrats, you have just made, if you followed along, your quicksort customizable with function pointers. Hooray! But we aren't satisfied by passing descending by reference. We want the real thing. We want a pointer object. Where will it be useful to have a pointer object? Now, suppose this comparator is used in multiple places. If we don't have it in a variable, we'll have to find all the places and change the reference there. And we don't want to do that. So we want something which can hold this value, some variable type, and we want to send this down. Now, how do we define this variable? Of course, we can go this way. But this still gives an error because this is not the way how it's done in C. We have to use the keyword typedef. Remember that? And the name of the function goes inside the bracket. Let's write it with the, yeah. Yeah. So this is the syntax, which is C style syntax for defining the name of a particular signature function pointer. It's quite awkward, wouldn't you say? Let's compile and run the program. It works, but we can do something better. C++ gives us another way of defining it, which is slightly less awkward. We can use the keyword using. So the way to do it is using comp, and then we write the function signature. Compile it, run it. Just for completeness sake, try the ascending as well. Yep, works. Okay, so far we have used pointer to regular functions. Let's take it a step further. We want to study pointers to member functions of a class. Right now, the member functions are floating around independently. Let's first put them in a class. Let the class be comparator. Right, and let's move it to the top of the file. Now, instead of having these functions floating around independently, they live under a single logical namespace. We can then create a pointer to the member function and pass it to the sorting logic. So how would you intuitively try to do that? Imagine we don't have this using statement. The way we did it initially was that at the place we just passed a reference to the function. Now this function is associated with the comparator class, so we are forced to create an object and pass in the function like this. Let's try to compile the program and see what happens. Okay, we get an error. Cannot create a non-constant pointer to member function. So what does that mean? Ignore the non-constant pointer to member function for now, because we're not covering constant and static variables at the moment. But what I want to highlight or want you to take from this is that a pointer to a member function is very different from a simple pointer to a function. Even though the object is initialized and this function is concrete, it exists somewhere in the stack, the reference exists not as a address, independent address, but as an offset to the object. So it does not have any independence of its own without the object of the class being provided. There is no way in which this means anything or can be used at all. That is what this error actually says, that this construction is not a valid C++ object. Okay, So let's try to get to square 1 using the passing the object of the class into the function and then using the function. So instead of this pointer, we will have a comparator comp. So what have we done? We have passed the object of the class around to the quicksort, and through that we have accessed the ascending function. Let's compile the code and run it, and it runs. But we are in a way back to square 1 because we have to change the code of the partition function to get a different result, as you can see. So how do we define a pointer to a member function that we can then use as well? The way it's done in C++ is by using this construction, comparator class name slash pointer. Looks familiar? We've just added the keyword comparator over here. Okay, but then you would say that why couldn't we just pass the pointer to the function like this? For the same reason that again we won't be able to use this independently of the object of class comp, because the pointer to a member function exists as, now just note this down, as an offset to the location of the comp object in the stack. Just to make it more clear, I will call it pointer to member function comp, and we will create an object of pointer to member function comp called cmp, and we'll have to pass both the object and the pointer only being applicable if we have an object of the type comparator. Pointer to member function comp cmp. Now finally we can use not cmp directly. No, this won't work. If sorry, we must state that this is the comparator function ascending reference. Yeah. Can we use the function like this? No, because it's associated, it has always a class object with which it is associated. What is the issue? Oh, we're using it before we've told the compiler what it is. There we go. So we have now passed the function just like before, but this time we are accessing it through a object of class comparator. This line is just like the pointer to a function in our previous uh, version of the code, except that it's now accepting a function from the class comparator, and because the reference is given as an offset from an object, the only way we can use it is if we pass the object to the class comparator as well. Hence, this is the way in which we can pass a pointer to a member function if it's available in the class. So let this settle down. Take a moment. It's a very powerful concept that we have learned today, that how we can have a pointer to a member function of a class. Great. Let that settle in. And now, just for a sneak peek for the final motivation, we'll look ahead at virtual functions. Let's look ahead to virtual functions, the mechanism behind polymorphism in C++. Suppose we have a base class foo with a virtual function bar and a derived class foo2 that overrides this function. We create a pointer to member function for the class foo and make an object of class foo2. If you look at the initialization, that just sets the int I to 10 for the object. Now we create a pointer, a pfoo pointer to the object, and now we try to call this function. This is the same as dot uh, syntax like we used previously, with the value 20. So now what would the answer be? Would the answer be 30 or would it be 200? Make your guesses as I compile the code. And the answer is 200. How many of you got it right? Put it down in the comments. I will explain this next time. Thank you for hanging on and see you around.